Good morning. My name is Harpal Gill, and I'm the VP of the Connects Group at Software AG. I'm joined by my colleague Bill Luton, Director of R&D, also in the Connects Group at Software AG. And today we're going to take a look at 3 secrets to unlock data value: data access, data virtualization, and data movement. We all know that the mainframe applications store and process high-value data. In fact, over 80% of the world's corporate data either resides or originates on the mainframe, everything from financial transactions, taxes, social security, and more. We're also seeing an unrelenting demand for that data. People wanting to access and integrate that data to be able to gain business insights and real-time access to analyze the data and develop new ideas. Or perhaps people want to drive self-service information, have that data at their fingertips, whether it be on a desktop device, a web device, mobile, or any other type of device. People also want to leverage the latest BI and analytical tools, be able to leverage what they have today from Excel or the various BI tools that are there, but also be prepared for something better and new that comes tomorrow. And finally, people are looking to consolidate that data from the variety of different applications into a data lake in the cloud, be able to leverage all that enterprise data in a single location for greater insights. And that data resides not only on the mainframe, but in a variety of different siloed data sources all across your enterprise, from mainframe, AS400, and a variety of different legacy platforms and modern platforms. So what are the challenges to realizing this data's value? Well, the data resides in a variety of different data formats. On the mainframe, we have everything from VSAM, IMS, DB2. In fact, we have dozens of different data sources. The other challenge is the speed of data access. People want to access that data in real time, as soon as possible, easily, and that is also a challenge. Sometimes the data isn't just in one data source that we want to access it, but it's in multiple data sources. So the concept of virtualizing multiple data sources into a single view is a challenge. And finally, it's a laborious process of getting that data. If you have that data and you want to access it via Excel, the challenge of taking that data, doing an extract, doing an FTP, and then an upload into a different application, are there better ways to do this perhaps? So what if you could empower your data analysts to do more? Everything from self-service analytics to just easy access from Excel or any modern BI tool, perhaps leverage their SQL skills. Well, let me share with you some of the scenarios that I hear. I had a customer that had VSAM and IMS on their mainframe, and they just wanted to provide simple Excel access to that user. Today, what they have to do is they have to do an extract from the VSAM data source, do an extract from the IMS, do an FTP of both of those extracts to another location, do an upload, and then leverage Excel on that data. Other things I hear are people would like to be able to leverage a variety of different BI tools, and each one requires quite a large and costly project to implement a process to give them access. Sometimes they just want to have read-write access with a simple front-end tool like Excel, and that also requires a fairly large project to do something with. So those are some of the challenges we hear. Well, now let's look at it from a customer perspective. What if you could provide better customer service? Things like self-service solutions, real-time data access, instantaneously look up inventory. Well, let me share some of the scenarios I've heard from customers that are trying to do things for their specific customers. In one scenario, we have a local state government that wanted to provide data access and location services to their constituents or their citizens. And they wanted the ability to disseminate data from the mainframe, from a couple of different databases, to a mobile device. Other things I hear, I've got consumers that are out in their various different locations wanting to do something as simple as easily look up on a mobile device or perhaps even on a web browser what inventory is in stock, where is the inventory available, and what's the current price. Or let's change gears and chat about an organization, a hotel organization, that wanted to just do something simple as extend the ability for their customers to have a mobile app or a web browser to book their stay, to check availability of rooms, pricing during different times and days and seasons. So those are the kinds of things we typically hear from people wanting to leverage the various different solutions better. Well, your data needs are unique and you need options. And that's where the Connect suite from Software AG gives you a solution. We have 3 pillars to our Connect solution: data access, data virtualization, and data movement. On the data access, again, we provide data access to desktop, mobile, cloud, and we support all the modern connectivity mechanisms, ODBC, JDBC, OLADB, and .NET, and support for over 150 different data sources and platforms. On the data virtualization, we give you the ability to virtualize multiple data sources into a single view for things like dashboarding, reporting, business intelligence. Again, leveraging that same standard connectivity mechanisms, but having the ability to access over 150 different data sources, whether they be on-premise, in the cloud, or hybrid. And finally, data movement from any of those 150 plus data sources to the cloud, to a data warehouse, or a hybrid of both. Let's drill into these a little bit deeper. Let's start with how to view any data from any data source via the Connect's data access or the Connect's database adapter. The database adapter delivers real-time data access to over 150 different data sources. It allows you to translate non-relational and relational and other data sources to SQL standards automatically. We leverage all the existing data source security mechanisms that are built in and in place, and we can extend the data to any modern BI tool that a customer may want today, or perhaps something that comes tomorrow. The benefits are quick and easy setup. There's not a costly project involved in doing this. You can leverage existing SQL skills and your consumer's Excel skills. We can address reporting requirements faster, and no data movement is required. At this point, I'd actually like to turn it over to my colleague Bill, who's going to take us on a demo of the data access component leveraging the Connect's database adapter. Bill, I'm going to turn it over to you.
Thank you, Harpal. For my first demonstration, I'm going to be showing data access using Microsoft Excel as my data visualization tool. The Connects Excel add-in, when installed, provides a new menu item called Connects, where we have a menu ribbon that has 3 buttons. We can use our existing connections that we've created. We have a wizard to create new connections, and we also have a data pane over here that combines all the functionality into one convenient location. So the first thing I want to show is a demonstration of just how easy it is to bring data in. So I've already created a connection, and I want to just show you that once a connection is created, how easy it is to bring data in. So I have a sample table that is a VSAM file sitting on my mainframe. It contains some customer information. For our demonstrations today, we're going to be using 3 different tables: customers, orders, and products. And my customer's information happens to be in a VSAM file. And I want to just show you how I can bring it in with just 2 clicks, or actually a single double click. So I have my connection here called Customers VSAM. I'm going to double click it, and the data is now brought in from the mainframe into Microsoft Excel as a standard Microsoft Excel table. We have code that actually runs on the mainframe where the SQL was sent to it. It broke it down into the low-level file I/O, gathered up the result set, sent it back, and Microsoft Excel actually doesn't have any idea that it came from a mainframe. It's just any other result set. In the case of Microsoft Excel, It used the OLADB interface to access it, but you can actually use Connects from any application that supports ODBC, OLADB, JDBC, or the .NET Data Provider. Later on in the demonstration, I'll also be showing an example of a .NET application called Infonaut that also ships with Connects and how we use the .NET Data Provider in that case. So that's how easy it was to bring the data in, but I want to show you a little bit about what's behind the scenes when we do that. So I'm going to create a new connection. And this time, instead of bringing data in from VSAM, I'm going to bring in some data from IMS. Now, the first thing we need to know when we make a connection is we have to point to something that we call our data dictionary. The data dictionary is our metadata repository that Connects uses that tells Connects how to connect to the various databases that you're interested in, inside the database, which tables you're interested in, within those tables, what columns are you interested in, if it's a flat file like VSAM, what are the offsets and lengths of the fields so that it knows how to parse the information. Basically, all the metadata necessary to access the information. So I have a CDD that I've created for this demonstration, and I'm going to open it up. And what it's presenting with me now is a list of the tables that are in this CDD that I can choose from. So earlier I had chosen the customers table from VSAM. This time I'm going to choose the orders table from IMS. And all I have to do is select it and click next. And now this Excel wants to know where do I want to store the file that contains the connection information, as well as what friendly name do we want to give it. So in this case, I'm going to call it orders underscore IMS, and that's going to show up as a name over here on the right. As soon as I click finish, now that connection got created and stored, and we actually went out to IMS and brought in our orders table. And the orders table is made up of the customer ID plus all the order IDs related to that customer. And so this is an example of data access where we're actually getting the data in real time from our mainframe data sources, in this case VSAM and IMS, and we brought them into a tool like Microsoft Excel, where then you can process it however your business needs need. And Harpal, with that, I'll turn it back over to you.
Thanks, Bill. So there we got to see data access leveraging the Connects database adapter to connect to mainframe files for real-time data access to allow things like self-service analytics from the desktop, mobile, or clouds. Well, let's build on that. Let's take a look at data access from multiple data sources in a single relational view, or what we call data virtualization. Again, we're leveraging the Connects database adapter to connect to multiple data sources and our metadata management model, which will allow us to view those data sources as a single data set. So we have the ability to define a single SQL view across multiple databases. And again, we support over 150 different databases. We're going to leverage standard SQL support for writing queries, the ability to leverage the integrated metadata management model to, again, consume that as a single data source, and real-time SQL access without moving any data. The benefits are you can achieve a single view of a customer or other business data for improved decision-making. You can hide the complexity of multiple, whether they be non-relational, relational, or other types of data sources on various different platforms, and real-time data access for dashboarding. So I'm going to turn it back to Bill to take us on a data virtualization demo of multiple data sources in a single view. Bill, over to you.
Thank you, Harpal. For my next demonstration, I'm going to use Microsoft Excel again, only instead of doing data access where we brought in a single table before, this time I'm going to show you a concept that we call data virtualization. And virtualization is when we take two or more data sources and combine them together to make them look like a single virtualized data source that then is brought into our tool, in this case Microsoft Excel, but it could be any BI tool that you would want to use. So we're going to, in the case I'm going to show you, I'm going to actually combine data from VSAM, DB2, and IMS, and I'm going to bring them in to Microsoft Excel. And Microsoft Excel is going to think this is just coming from one single database and a single table within that database. And so that's what we mean when we say data virtualization. So I've already created a connection here, and I'm going to edit this connection so that you can see what I did. So if you recall before, when I wanted to bring in a single table, I just selected this one table and clicked next, and I just said this is what I just want to bring in this one table. Well, we also have the ability to actually have a query, a SQL query, be the source that we're going to bring in. And in this case, my SQL query is actually a three-table join, where I have my customer information in a VSAM file, I have some order information in an IMS table, and I have some product information in a DB2 table. Now, this input area, you can freeform type your query in. But if you're not good with SQL, or your query is real long and you don't want to do a lot of typing, we do also have a query builder tool. And what this does is it gives you a visual view of the query that you're going to build. And I'm going to undo this a little bit so you can kind of see how it's put together, and then I'll just hit cancel when I'm done, because I'm sure I'll make a mistake. Here, let's take out some of our columns so that you can kind of see how this works. So the first thing, in fact, let's just pull that table right off of there. So the first thing, I have a couple tables up here. I have the customers VSAM and the orders IMS. And then we're also going to need from DB2, we're going to need products. So I'm going to grab the products table and drag it over. Now, these tables are actually, it's a virtual relational database, if you will. So these tables are actually, we can make them related, and I'm going to join them between my customers and my orders. I'm going to join them on the customer ID, and between the orders and the products, I'm going to join them on the product ID. Because see, in this product table, I've got things like the product name, stuff so that it makes it readable, so you know what's going on. And if you notice down here, let me do this one join again real quick. As I make these joins, pay attention down here, you'll see that the tool is actually building this query as I go. So you'll see that we just added another inner join. Now, if I want to add some column names to my query, you'll see that it's adding column names to this query. And this is just a nice, easy visual way to not only see what the query, visually what it's going to look like, but to also help you build queries if you're not familiar with it. Now I'm going to go ahead and hit cancel because I have it built out here. And once we have this built, just like before, the only other thing Excel needs to know is where do we want to store the connection information on the hard drive, and what do we want the short name, or the friendly name, to be. And I called this custord prod virt. Probably not real friendly, but I'm going to go ahead and hit cancel, and then we're just going to run the one that I had here. And again, I'm just going to double click it. And now what we've done is we've done a three-table join across three different databases on the back end. Now, they happen to have been sitting on the same machine, but they didn't have to be. They could have, been one on a machine in Bellevue, where I'm at. One could have been on a machine, in Germany, where the Software AG headquarters are. It doesn't matter. As long as we have a TCP/IP connection to all of them, we can pull the data in from anywhere. And in fact, these are the source is actually three completely different database systems. Like I said before, VSAM, IMS, and DB2. As far as Microsoft Excel is concerned, this is a single table that came from a single database. It doesn't know anything about the back end. We brought it in. It's now in a Microsoft Excel table. and you can manipulate it now as your business requirements need. And of course, it doesn't have to be Excel. I'm just using that as my tool for today, but any BI tool that supports ODBC, OLADB, JDBC, or the .NET data provider will give you access to this. And so this is my example of data virtualization. And Harpal, I'll turn it back over to you.
Thanks, Bill. And that was our data virtualization demo. We got the ability to view data from multiple data sources as a single relational data source for consumption by various different tools. So now let's take a look at data movement. Move your data to wherever it is needed. We have the ability to have near real-time data movement to a data warehouse or data lake on-premise or in the cloud, or perhaps hybrid. We have out-of-the-box adapters for Teradata, Oracle, AWS, Azure, Snowflake, in fact, over 150 different data sources that can be used as targets. We have a powerful ETL solution, so rather than just do extracts and loads from the source systems to the data warehouse or data lake, we can transform that data in flight so it can appear as you need it in your data target. We can also replicate incremental changes, so we're not always doing full loads, extracts and loads, but rather just moving the changes, or what we call change data capture. The benefits are all your data, enterprise data, is in one location for BI and analytics, and you can make better data-driven business decisions. So I'm now going to Bill to do the last demo that we're going to see on our data movement, leveraging the Connect's data sync solution.
Thank you, Harpal. For my next demonstration, I'm going to show data movement. And we're going to be doing data movement with the Connect's Data Sync tool. Data Sync is a web-based tool that moves data from any of our 150 plus supported databases to any of our 150 plus supported databases. Not only does it move the data that's in each table, it also can detect changes and then only move those changes. Now, Data Sync as a tool can do either extract and load or extract transform load, or ETL. The extract load capability is just the ability for us to copy a source table to the target in exactly the same form that it was in the source. The transformation piece allows us to actually modify the metadata between the source and the target. So for example, we can add tables, or I'm sorry, we could add columns, or we could remove columns. We can change data types, column names. We can also introduce the idea of data virtualization that we saw earlier as the source for our change data capture. And I'll be looking at that in a little bit later in this demo. Now this tool normally you would run on a schedule, and in fact I have a schedule set up in the background that will fire, that should be firing any moment now. Normally you would set up and say you want certain tables to run. Oh, there we go, we're running now. So I have some test tables that are synchronizing. They're just moving data between a couple SQL servers I have back in my lab. And what we can see here is a little speedometer that shows us how we're doing processing speed. I have how far along we are, statistics that tell us where things are at. And then, of course, I have my history down here. Now, the other way we can run things was what we just saw was an example of a scheduled set of synchronizations firing. We can also run in an ad hoc method, and that's what I'll be doing for the demonstration, because I don't want to actually have to sit and wait for certain schedules to fire. So I'll set things up and I'll run them immediately. You might also want to run them that way in a production environment. Simply as a way to, maybe you're getting ready to run some ad hoc reports and you need to move some data to take care of that, or perhaps you're building transformations and you need to test them first. You would do those in an ad hoc manner. So the first thing I want to show is a basic extract and load. And I'm going to just select the three tables that we've been using. I've got my VSAM customers table, I have my IMS orders table, and I have my DB2 products table. And this time, or not this time, we're going to be moving the data from the mainframe, and we're going to be moving it out into the cloud into an Azure DB. So I've already set up Azure DB as my default target, and I'll just show you here real quick. And so anytime I'm just doing an ad hoc movement like this, it's going to go to my default target, and I have that set up as Azure, and so that's where all of these are going to go. So I'm going to select my 3 tables, and I'm going to click Sync. Now, when we're doing a sync, the first thing we need to do, if we're interested in change data capture, before we can worry about change data capture, we need to have our source and our target tables completely in sync. And so the first thing we want to do is a full reload. What the full reload is going to do is it's going to actually truncate the data out of the target table, and then it's going to copy all the data from the source to the target. And because we're doing the table synchronizations as opposed to transforms, our source and our target are going to have exactly the same metadata, same data types, same column names. Everything will be the same. So I'm going to go ahead and click OK, and our full reload is going to run. And these are small tables, so you see it went pretty fast. But if I refresh, we'll see them down here. Now, let's open up my connection to my Azure database. And the first thing that we're going to look at, I'm going to look at this customers table. And so up in my Azure demo database, I've got customers, and I'm going to run a query against that. And we'll see that we have the same customer data that we were looking at before. This is the data that came from my VSAM file and is now actually all the way up onto my Azure DB. Okay, so now that we have the full reload done and the table in Azure DB is fully loaded, let's look at what happens when we make some changes on our source and how those get moved. So earlier I had alluded to other tools besides Microsoft Excel. This is a tool called Infonaut that ships with Connects, and it's a .NET application, and so it uses the .NET data provider. It also connects to the CDD, and I'm using the same CDD that we've been using, and so I have access to my customer's VSAM file. And this is that same customer's file, and we're going to make a modification to it. So let's change the always open quick mart to say that instead of being in Seattle, I'll say it's in Bellevue. Bellevue is actually a city that's east of Seattle. It's actually next door to Redmond, and Bellevue is where our offices are. And so I'm going to say Bellevue. Now, because data sync is a batch type tool where the synchronizations happen either on a schedule or on demand, the data hasn't actually moved yet. So we've made the change in the VSAM file, and now we want to tell DataSync to go out and analyze that VSAM file, figure out what changed, and then only move those changes. So if I come back to my tables and I'm going to select my VSAM file, I'm going to click Sync. And now I'm going to tell it to do an automatic sync. And what automatic does is the tool will go out and it'll analyze the source file. And if there are too many changes, it will just do a full sync, because there comes a point that it's faster to just do a full sync. But if the number of changes is below a threshold value, which is configurable, then it will do an incremental sync, or it'll just move the changes. So I'm going to click OK, and we're going to come back, and it's again, it was so fast we didn't actually see much information, but we can see it here that the incremental ran and it detected the one update, and it moved that to the Azure DB. So now when I come up here to my Azure DB and I refresh my view here, we'll see that Seattle changed to Bellevue. Okay, so these are examples of doing extract load type, not only to do the full sync, but also picking up just changes that we made and only moving those changes to our target. So now I want to show you transformations. So as I said earlier, transformations can be anything from I just want to map, perhaps my source columns are not quite the same as my target, so I just need to kind of do column mapping. Perhaps my data types I want to be different between my source and my target. Something that's actually very common is the target table might already exist because it fits a particular format that some other tool uses, and you need to map the columns from your source into that format. And that would be a very common method of a common type of transformation. Another common type of transformation is adding a column. For example, a timestamp. You might want to have a column that shows the timestamp for any time a column was added, or I'm sorry, a record was added or modified in the source. You would want to have a timestamp that would end up on the target that would tell you what time that happened, and that would be another example of a transformation. First thing I'm going to do with transforms, I'm just going to create a dummy transform and kind of show how some of those things work. So I'm going to select my source. Let's just do DB2 customers is fine. And I'm going to select a target. We'll call this DB2. It doesn't matter because I'm not going to actually save this one. And we're going to say next. And this brings me to my column mapper. I just wanted to show you some of the sorts of things that you can do. As I alluded to earlier, I can add a row, and perhaps I might want to call this change time. That would be the time that something was changed. Oh, I'm sorry. I'm getting ahead of myself. I would want to put in a function. We have a function in Connect called curTime that will give me a timestamp for the time that I want to use. And then in my target, I might call this change time. And I might want to make that a timestamp field. And that way now, anytime something changes in my source, I'll drop this extra field in on my target with a timestamp. And then I can move this down a ways. Perhaps I don't want it that far up. I'll move it down to the bottom. I can also do things like I can just do things as simple as change field names. I can also maybe customer name is the second field here, but it actually maps to something that's the fifth field over here. I can map them that way. I can also change data types. So for example, customer ID, perhaps it's actually made up of numbers, and I want it to be an integer value on my target. So I'm going to make it a 4-byte integer. Now, the thing to remember or keep in mind here is if you're going to do something like this, where you're changing characters to integer, the data that's actually in the table needs to be compatible. In my particular customer table, I don't know if you were paying attention, but all my customer IDs are actually 5-character alpha fields. So this wouldn't work because they're actually letters. They don't map to any numbers. And so what would happen is, as the target database was trying to do these data conversions, it's going to throw back errors and say, hey, these aren't compatible. I know Oracle will complain and say that they're not compatible. I think, if I recall, SQL Server might attempt to convert them, but they'll all end up being 0, and then you get duplicate key errors. So you do need to be careful that when you're doing transformations, that what you're doing is in fact legal and valid. So I'm going to go ahead and hit cancel and take a look at another type of transformation that I've created that I want to show you. And this is a transformation that's actually based on that same 3-table join that we looked at earlier as our source. So instead of even needing to have a source table, I can have a virtualized source that will then be combined and put into my target as an actual physical table. So this is that same three table join where I joined the customers data from VSAM, I joined the orders data from IMS, and I joined the product information from DB2. And we're actually going to run this one. So when I just step through, I've created a table out there called orders report that's in my Azure DB database. And we'll take a look at that in just a moment. And I'm not going to do anything with column mapping because my source is made up from my SQL. If I want to change my source, I actually just need to change my SQL. And in this case, actually my target is the way I want it. So I'm just going to accept my column maps. Now, when we're doing a three table join, we do have to pay attention to the index. There's one aspect of this that I didn't mention earlier, and this includes even the extract load side of things. If we're going to do change data capture, meaning we're going to pick up updates and deletes, we need to have a unique index on the target because we have to be able to find the record that you updated or deleted. So we have to have a way to find that, and it has to be unique. In our case, because we have a three table join, the tool is probably not going to be able to figure out necessarily what your unique data is because the customer ID happened to be the index on the customer table, order ID was from order, and product ID was from product. But when we combine them together, they may or may not be unique, depending on what your data looks like. Now, in my case, they happen to be, but I actually had to build this index description where I happen to know my data and I was able to say, yes, customer ID, order ID, and product ID combined make up a unique index. So once that's set up, then just like before, we're going to do a full sync. And we'll see it. It ran faster than it was able to refresh the screen, but we have all of the records out there now. And so I'm going to come back now to my orders report from my Azure DB, and I'm going to execute this. And now what we see is a physical table in Azure DB that's actually made up of the VSAM file for customers, the IMS orders table, and the DB2 product table where I got the product name out of. And you can see that it's now a physical table. Now you notice this always open quick mart, we actually have 3 records for it now. And that's because in my data, I actually have 2 distinct order IDs for this customer. I have 101 and 84. And then within 101, I have 2 distinct product IDs. So this actually makes up 3 records. And that's important because what we're going to do now is we're going to come back to our customers table again, and we're going to change Bellevue back to Seattle. Now, instead of just analyzing a single table, DataSync is going to analyze all 3 tables and figure out what changed. It's going to discover that a record in the customers table changed, but that record actually affected 3 records in the target. So let's go back to our browser and run our transform again. This time I'm going to do an automatic like before, and it's going to analyze all of my tables. And again, I think we've got other stuff running. I think that one probably is already done. It went through. Yep, it's already done. And we're going to come back. And you'll notice, remember, before it was 3 Bellevues, and I'm going to rerun the query, and 3 Seattles. So this is an example of a transform using virtualization as our source and going to a single concrete target. And with that, Harpal, I'm going to turn it back over to you.
Thanks, Bill. And that was our data movement solution, leveraging the Connect's data sync solution. Again, we can move data from over 150 different sources and platforms to over 150 different targets, either on-premise or in the cloud. So in summary, the Software AG Connect's solution offers a data solution, data integration solution that provides a data access, a data virtualization, and a data movement solutions. Our data access was our Connect's database adapter, and it provided data access to over 150 different data sources, whether they reside on the mainframe, the AS400, or any other Linux, Unix, Windows platform. On the data virtualization, we also provided the database adapter technology in addition with a single metadata manager that allowed you to have multiple data sources virtualized into a single view. And again, these data sources, over 150 different data sources, can reside on the mainframe, AS400, or other Linux, Unix, Windows platforms, or even the cloud. And finally, our data movement solution, the Connect's data sync product, which moves data from any of the 150 plus data sources we identified being on the mainframe, AS400, Linux, Unix, Windows, or in the cloud, to any cloud or on-premise or hybrid platform for a variety of uses, whether it be analytics, data warehouses, data lakes, and such. I'd also like to point out that the Software AG Data Integration Suite is part of a larger suite on legacy integration. We have integration solutions that meet your specific needs, whether you're looking to do legacy integration at a screen level, at a code level, APIs, or the data level, as we just saw. The legacy modernization and process optimization with REST APIs. We can do bi-directional APIs and services for legacy application integration. And then real-time data access, data virtualization, and integration, as we saw with the Connect suite. And finally, we can connect Cobalt to REST APIs in just 10 minutes and unlock data in just 2 clicks. So with that, I'd like to just end with, if you'd like to learn more or request a demo, please visit us at softwareag.com/mainframe. Thank you for your time.